Welcome to all the presentation. So here this is the course plan. Introduction to soft computing, evolutionary computing, introduction to soft computing. After that, the first module is module 1 is introduction to soft computing. On that, the second module is evolutionary computing. Okay, I want to share my the screen to you, all of you. Just see this introduction to soft computing, the first module 1, module 2, evolutionary computing. Under the subcategories genetic algorithms, other one is simulated annealing, the other one is the optimization, the other one is swarm optimization. So the third module is fuzzy logic. On that fuzzy logic, the submodules is fuzzy set, fuzzy logic, fuzzy algebra, and fuzzy reasoning and fuzzy classification. The fourth module is artificial neural networks. Okay, and that the submodules is different artificial neural networks, learning with artificial neural networks. Advanced topics. Mixed hybrids of computing is an advanced topic. FLGA. So hidden Markov modeling. Support vector machine. These are the advanced modules. These are the references books, of course. So references. So in that, the next one is introduction to soft computing, and on that we have to cover concept of computing, importance, characteristics of computing, soft computing versus hard computing, few examples of soft computing applications, characteristics of soft computing, hybrid computing. We have to cover like this. Okay. Concept of computing. You can observe very clearly here the concepts of computing. So just see the diagram. Computing. Capital Y is equal to small f of x. Okay. The input is so architectant and consequent is the output. Here the control action of the computing. Y is equal to f of x. F is a mapping function. Small f is a mapping function. F is also called as formal method or an algorithm to solve a problem. So here important characteristics should the first characteristic is should provide a precise solution. This is the first characteristic. Should provide a precise solution. The second characteristic is control action should be unambiguous and accurate. The third one is suitable for problem, which is easy to model mathematically. So, hard computing, the term hard computing. So, hard computing precise result is guaranteed. Control action is ambiguous. Control action is formally defined with mathematical model. Examples: solving numerical problems, roots and polynomials and integrations. Okay, so examples and another example is searching and sorting techniques. Solving computational geometry problems. Example, shortest Turing graph theory. Finding closest pair of points. You can observe here there are mathematical concepts are there. Okay. Problems in some other areas of applications. Medical diagnostics. Where we have to apply these soft computing methods. Problems in some of the areas of applications. Some of the areas of applications I want to mention the what are the problems. Okay. Here I have to mention that problems. Okay. So in the chat box, what are the problems are there? Problems in some other areas of applications. Okay. So here in this, I have to medical diagnosis. First problem is this is very important because application oriented learning is very important now. That's why the reason medical diagnosis and other one is person identification, computer vision, person identification and computer vision. Person identification and computer vision, handwritten character recognition, handwritten character recognition, pattern recognition and machine intelligence, pattern recognition and machine intelligence. Just observe this the application. This is the heart of the course, of course. Weather forecasting, weather forecasting. Okay, so VLSI design and network optimization. Network optimization. Okay, so these are the different types of problems in some other areas of applications. Medical diagnosis, person identification, computer vision. Medical diagnosis means you have to diagnose a problem in the medical applications. What are the different types of problems are there in the medical oriented fields? Medical oriented fields, what are the different types of problems are there in the medicine? Okay, coming into, you have to diagnose those problems, you have to identify that problem. Okay, so then only the cure we should, then we will find a solution for the cure. Okay, so first diagnosis of the problem is very important, identifying the problem is very important, so that is called medical diagnosis. The second point is personal identification. Personal identification, so identifying a person in a organization. Okay, that is called personal identification. Computer vision. Okay, so vision of a computer, so using the, so what are the so vision of a computer, that means what are the various uh, things in the modules are there in a our project. Okay, you have to list out that, you have to find out that. Okay, using the soft computing. Handwritten character recognitions, so handwritten characterization and pattern recognition and machine learning, mi, pattern recognition and machine learning. Okay, so weather forecasting means how to how was the weather is, whether it is a degree of hotness, a degree of coldness, or medium weather, or too much cold or too much hot. We can identify by using the soft computing techniques for the weather forecasting application area. This is one of the application area. So chip designing, VLSI design means chip designing field and the fabrication purpose. So on that, it is very useful in the chip designing field. Network optimizations. So coming into that, local area networks, wide area networks. So, what are the different types of networks? What are the different type of addresses, IP addresses? Everything we should optimize using this network optimization technique. Okay, this is very important. Characteristics of soft computing. It does not require any mathematical modeling of a problem solving. That's the first important point. It does not require any mathematical modeling of problem solving. Then the next one is, it may not yield the precise solution. It may not yield the precise solution. Algorithms are adaptive. It can adjust the to change of dynamic environment. So the next one is, use some biological inspired methodologies such as genetics, evaluations, and behaviors, practices, swarming, human nervous systems, etc. Biological inspired methodologies. Human nervous system is one of the examples. These are the characteristics of soft computing. So hybrid computing. It is a combination of conventional hard computing and emerging soft computing. HC, hard computing, SC, soft computing. This is the both combinations is nothing but hybrid computing. Problems ponder, hard computing versus soft computing. Limitations in hard computing and soft computing. Examples of only hard computing and only soft computing. Examples of hybrid computing. So like that. Okay, this is the first module of presentation. The next module I will open. Just 1 minute, I will open the next module of my presentation. The next module. Next module is introduction to genetic algorithm. Next module is introduction to genetic algorithm. So here the limitations of traditional optimization approaches. What are the limitations? Computationally expensive. For a discontinuous objective function, methods may fail. So, and the third point is methods may not be suitable for parallel computing. The fourth point is discrete and integer variables are difficult to handle. The, the other point is methods may not necessarily adaptive. Evolutionary algorithms have been evaluated to address the above mentioned limitations of solving optimization problems with traditional approaches. Evolutionary algorithms, the algorithms which follow the biological and physical behaviors. Okay, biological behaviors. Okay, genetics and evaluation, genetic algorithm. This is, please kindly note that once again I'm repeating, genetics and evaluation. So genetic algorithm is used depending on application. The algorithm is used. What type of application we are using, what type problem we are solving. To find the solution to the practical oriented problem, we are using that particular algorithm. Behavior of art colony optimization. So human nervous system, artificial neural network, human nervous system, artificial neural network. In addition to that, there are some algorithms inspired by some physical behaviors. So annealing process, simulated annealing, swarming of particle. So particle swarming optimization, learning, fuzzy logic. So yeah, genetic algorithm, it is a subset of evolutionary algorithm. So ant colony optimizations appoints as swarm particle optimization, model of biological process, genetics evaluation, to optimization, highly complex objective functions, very difficult to model mathematically. First point is NP-hard, also called as combination national optimization problems, which are computationally very expensive, involve large number of parameters, discrete or continuous. So first time introduced by the at US. Okay, so principles of genetic algorithms are based on the fundamental biological process, genetics and evaluation. A brief accounts of genetics. The basic building blocks of living bodies are cells. Each cell carries the basic unit of heredity called gene. So you see the diagram. So chromosome. So and the clear means other bodies of the cells. For a particular species, number of chromosomes are fixed. Examples. So mosquito. So frogs, human, goldfish, like that. The chromosomes vary based on that. Okay, genetic code. So, spiral helix of a protein substance called DNA. The for a spice DNA code is unique. That is very uniquely from one to other. DNA code inherits some characteristics from one generation to next generation is used to biometric tract. A brief account on genetics reproduction. Gamete. So this type of diagram, organism cells divisions you observe in the reproduction in the diagram itself, of course. So a brief account of genetics. You can observe the diagram again. Information from two different organizations of the bodies of cells. Random crossover points makes infinite diversities. So so combined so that diversity in information is possible. So a brief account of evaluation, information propagation, okay, and offspring, so many of its characteristics, okay. So population diversity, survival of existence, survival of the best. So mutation to make the process so pursuably dynamic when variation in population going to stable. A brief account of evaluation. Biological processes. See the diagram. Population. So mating a pool. So mate selection. So mating offspring, new population. Definition of genetic algorithm. Genetic algorithm is a population-based probabilistic search and optimization techniques, which works based on the mechanisms of natural genetics and natural evaluation. And framework of genetic algorithm: start, initial population, coverage, stop, selection, reproduction. Genetic is an iterative process, working of genetic algorithm. It is a searching technique, working cycle with or without convergence. Solution is not necessarily guaranteed, usually terminated with a local optima. Framework of genetic algorithm. Just see this diagram. I want to enhance this diagram. Just see the diagram. Flowchart it is, of course. Start. Genetic algorithm framework. Initialization population. Genetic algorithm is very hot of our course. So define parameters. Parameter representation. Create population. Coverage. And stop. Evaluation fitness. Select mate. Apply cost function to each of the population. Crossover, mutation, so inversion, like that. Okay. Optimization problem solving of in genetic algorithms. For optimization problems, identify the following: objective function, constraints, input parameters, fitness evaluation. It may be algorithm or mathematical formula. So encoding, decoding, GA parameters. In fact, GA implementation involved with realization of the following operation: coding, how to represent a solution fit with GA framework. Okay, genetic algorithm framework, convergence, how to decide the termination of criterion. So, mating pool, how to generate next solutions, fitness evaluation, how to evaluate a solution, crossover, how to make the diverse set of next solutions. So, mutation, to explore the solutions, in an inversion, to move from one optima to other. So, different type of GA strategies: simple genetic algorithm, steady state genetic algorithm, Macy genetic algorithm. So here simple genetic algorithm flowchart you have to see here. Genetic algorithm flowchart: start, create initial process of size and evaluate each individuals. So and criteria, you should take condition, you have to test yes or no. So here yes or no. Convergence of other meet yes. Return the individuals with best witness value no. Select NP individuals with reputation stop. So create mating pool randomly. Pair of parents for generating new offering. Perform crossover and create new offsprings. So mutuate the offspring. Perform inversion on the offspring. Replace the individual's last generation with the offsprings is created. Soft computing applications. See the soft computing applications. HEA parameters: initial population size, capital N, size of mating pool. So convergence threshold, mutation, inversion, crossover, silent features in yeah, SGA, simple genetic algorithm features have overlapped generation. Only fraction of individuals are replaced. Computationally expensive. So good when the initial population size is large. In general, gives better results. Selection is biased towards more highly fit individuals. Hence, the average fitness of overall population is expected to increase in succession. The best individuals may appear in a iteration, any iteration. Steady genetic algorithm. Just see the flowchart here. Start. Generate with initial populations of size n. Evaluate each individual. Select two individuals. So without repetition. Crossover, mutation, inversion, and if condition is yes, what happened? Condition is yes. Reject the offspring influences. Yes. If it is no, evaluate offspring. If the offspring is the better than the worst individuals, then replace the first individuals of the with the spring. Convergence meet. Return the solution. Stop. SGA futures. Generation gap is small. and only to offspring that are produced in one generation. It is applicable. Population size is small, so chromosomes are of longer length. Evaluation operations is less computationally expensive. So compared to duplicate checking. Silent features in steady state genetic algorithm. Limitations of steady state genetic algorithm. There is a chance of stuck at local optima if crossover mutation inversion is not strong enough to diversity the population. Premature the convergence may result. It is susceptible to strategian. Inferiors are neglected or removed and keeps making more trials for a very long period of time without any gain. Long period localized search. Okay, this is the regarding to that. Next module I want to present now. Next module. Next module is solving optimization problems. And this is introduction to solving optimization problems. Concept of optimization problem. Defining an optimization problem. Various types of optimization problems. Traditional approaches to solve the optimization problems. Limitations of traditional approaches that we have to discuss these topics. Optimization. Optimization value that is either minimum or maximum value. Small y is equal to capital F of x. Okay. For example, can we determine optimized value for y? So we just observe here. Okay, there are really not related to the optimization problem. Suppose we are to design optimal pointer made of some material with density rho. The pointer should be as large as possible, no mechanical breakage, and deflection of pointing and should be negligible. The task is to select the best pointer out of many possible pointers. So, okay, so here the problem can be stated as objective function subject to an optimization problem can be formally defined as well as maximize or minimize subject to mathematically define the following optimization problems. Traveling, okay, a salesman problem. So knapsack problem, graph coloring problem, job machining assignment problem, point change problem, binary search tree construction problem. Type of optimization problem. Unconstrained optimization problem. Problem is without functional constraint. So minimize. Type of optimization problem, constant optimization problem, optimization problem that can that with at any one or more functional constraints. Okay, types of optimization problem, integer programming problem. If all the design variables take some integer values, just observe these integer values here. X1 comma x2 are the integer variables. Real valued problem. If all design variables are bound to take real values. Mixed integer programming problem. Some of the design variable are integers and test the rest of the variables take the real values. Some are integers and some are mixed integer programming problem, that is. So linear optimization problem, both objective functions as well as the constraints are found to be some linear functions of the design variables. Okay, just see this x1 comma x2 greater than or equal to 0. Non-linear optimization, if either the objective function or any one of the functional constraints are non-linear functions of design variables. Non-linear functions they are. Okay, x1 square 5x2 cube So these are the non-linear functions. Traditional approaches to solve the problem. Optimization methods, linear programming method, non-linear programming method, specialized algorithm. So graphical method, simplex method are the linear programming. Non-linear programming is single variable, multivariable. Specialized algorithm, dynamic programming, branch and bond. So greedy method. So divide and conquer. Numerical method, analytical method, single value means, multi-value means constrained optimization, unconstrained optimization. So here elimination method, okay, interpretation method. So here elimination method again the unrestricted method, exhaustive method, Fibonacci method. So deterministic search, golden selection method. So in the information method is quadratic, cubic, direct route, and constraint optimization means here unrestricted method, exhaustive method, Fibonacci method, Lagrangian method. Unconstrained method means random walk. So univariate method, pattern search, steepest descent, conjugate gradient, quasi neutron, variable match, like that. Example, analytical method. Suppose objective function y is equal to f of x, let f of x be a polynomial degree of m greater than 0, y dash or y prime is equal to f prime of x is equal to 0 for some x is equal to x star, then we say that y is optimization. Either minimum or maximum point exists at the point x is equal to x star. Y prime is equal to f dash of x not equal to 0 for some x is equal to x star, then we say that there is no optimization value at x is equal to x star. X is equal to x star is an inflection point. An inflection point is also called as saddle point. So note, an inflection point is a point that is neither be a maximum nor be a minimum at that point. Following figure explains the concepts of minimum, maximum, and saddle points. Just see this diagram: maximum, minimum, and saddle points. So analytical method. Let us generalize the concepts of analytical method. If y of y is equal to f of x is a polynomial degree m, then there are m number of candidates points to be checked for optimum and or saddle points. Suppose y n y power n is the nth derivative of n. Case 1, y power n not equal to 0, n is equal to odd number, then x star is an inflection point. Case 2, y prime of n is equal to 0, for n is equal to odd number, then there exists optimum point at x star. So analytical method, in order to decide the point x star is a maximum or minimum, we have to find it next higher order derivative of y of n plus 1 is equal to f of n plus 1, x is equal to x star. So y of the same case, y of n is equal by just like as previous case 1, case 2. In case y power of n is equal to f power of n, x is equal to x star is positive, then x is a local minimum point. Y power n is equal to f power n, x is equal to x star is negative, and x is a local maximum point. Okay, y is equal to f of x, d square of y dx is equal to positive, and x is equal to x star 1. D power 4 of y of y dx is equal to negative, x is equal to x2 star. D power 6 by x is equal to plus or minus negative. Positive, x is equal to x3 star. Determine the maximum or minimum or saddle points. Okay. For any function, we have to define maximum, minimum, and saddle point. Limitations of traditional optimization approach. Computationally expensive. For a discontinuous objective function, the method may fail. These are the limitations of this method, actually. In this, we should observe condition true or false. Like that, case 1, case 2 be analyzed in a mathematically. So that you can observe the mathematical observations very clearly. So these are limitations for these methods. Optimization method is computationally expensive. For a discontinuous objective function, methods may fail. Method may not be suitable for parallel computing. Discrete integer variables are difficult to handle. Methods may not necessarily adapt to some computing techniques have been evaluated to address the above methods. I mentioned limitations of solving optimization method with traditional approaches. This is very important. Soft computing, I want to post in the chat box. Okay, see this point. Soft computing techniques have been evaluated to address the above mentioned limitations of solving the optimization problem with traditional approaches. Okay, so the next module I want to proceed. Next thing, just understand that point very clearly. Next, I will apply explain about the fuzzy logic control. Explain about the applications of fuzzy logic. About fuzzy logic. Applications of fuzzy logic. Concepts of fuzzy theory can be applied in many applications, such as fuzzy reasoning, fuzzy clustering, fuzzy programming, etc. Out of all these applications, fuzzy reasoning, also called fuzzy logic controller, is an important application. Fuzzy logic controllers are special expert systems. In general, fuzzy logic control employs a knowledge based expressed in terms of fuzzy uh, inference rules and fuzzy inference engine to solve the problem. We use fuzzy logic controller where an exact mathematical formulation of the problem is not possible or very difficult. These difficulties are due to non-linearities of time varying nature of the process. So large unpredictable environment of disturbances. Okay. So in general scheme of fuzzy controller is shown in the figure. Okay. So fuzzy rule base, fuzzy interference engine, fuzziation module, process to be controlled, conditions, actions, input, output, fuzzy systems, fuzzy logic controller. The general fuzzy logic controller consists of four modules. First one is fuzzy rule base. The second one is fuzzy interference engine. The third one is fuzzification module. The fourth one is defuzzification module. Fuzzy systems, fuzzy logic controller. Okay, as shown in figure 1, see the diagram. Fuzzy logic controller operates by replacing the cycle of the following four steps. The first step is measurements of inputs are taken of all variables that represent relevant condition of controller process. The second step is these measurements are converted into appropriate fuzzy sets to express measurements and uncertainties. This step is called fuzzification. The third step, fuzzified measurements are then used by the inference engine to evaluate the control rules stored in the fuzzy rule base. The result of this evaluation is a fuzzy set. Several fuzzy sets defined on the universe of possible actions. The output of fuzzy set is converted into single crisp value or a vector values. This is the final step called defuzziation. The fuzzified values represent actions to be taken by the fuzzy controller. There are two approaches in the fuzzy logic controller. No. So, one is Mamdan approach, the other one is Takigi approach. So, Mamdan approach is so fuzzy modeling and characterized in its high interpretability and low accuracy. So, on the other hand, so the other approach is fuzzy modeling and obtains high accuracy. One is low accuracy model, other one is high accuracy, but as a cost low interpretability. Illustrate two approaches with two examples. Consider control of navigation of a mobile robot in the pressure of a number of moving objects. To make the problem simple, consider for four moving objects, each equal size moving in the same speed. Typical scenario you should see in the figure 2. In the moving of mobile robot, one of the example, we consider two parameters in the mobile robot. D, capital D, the distance from the robot it can to the object, and the theta is the angle of motion of an object with respect to the robot. The value of these parameters with respect to most critical object will decide an object called deviation. So we assume the range of values, okay, in meters and theta in degrees. And after identifying the relevant input and output variables of the controller and their ranges values, okay, each of them appropriate by the fuzzy sets. Okay, so for current examples, we consider the following. So the states of these parameters. Distance is represented in the four states. We are very near, near, very far, far. Angle. We have to represent in the four states. Left. Okay. A head left. A head right. A right. Like that. So three different fuzzy sets are. I think you can understand this logic. I think three different fuzzy sets for three different parameters are given below. Okay. Once fuzzy sets of all parameters are worked out, our next step in fuzzy logic design is decided fuzzy rule base of the fuzzy rule base. Okay. Note that rule-based deadlines so 20 rules of all possible instances. These rules are simple rules and take in following algorithms. Rule 1. So if distance is Vn and the angle is Lt, so distance is far. So angle is A, then we should calculate in various probability combinations. Okay, distance near, far, like that. The next step is classification of inputs. Let us consider at any instantly the object is critical to the mobile robot. Okay, so we are applying all these concepts just to observe the distance or angle, tilt, very near, very far, or left angle or right angle, very right near angle. Everything we are applying to the mobile robot. So how the robot is moving like that. Hence we have to determine the membership values of the corresponding these values which follows. Okay, there are many rules in the rule based and all rules may not be applicable. So distance near, angle is A, then deviation. The distance is NR, angle is AR, then deviation. So the distance is FR, angle is AA, then what is the deviation? If distance is FR, angle is AR, then what about the deviation? Minimum points, maximum points. Fuzzy output. The next step is to implement fuzzified outputs corresponding to each five rules. The working principle doing this is first discussed and then we illustrate with running examples. Suppose only two fuzzy rules R1, R2 and R2 for which we have to decide fuzzy output. R1. Okay, so then what happens? The rule R2. Okay, fuzzy variables are S1, S2. This is the fuzzy output. Just examine that graphical representation of diagram. Note we take so minimum membership functions for each value function values for each rule. Output member function obtained by agreeing the membership functions of the result rule. Fuzzy output is nothing but fuzzy overall of output rules. Four rules. You observe graphically. I will explain. I already explained critically. Just examine the diagram. For rule 1, rule 2, rule 3, rule 4. They are the conditions with various conditions. Illustration mobile robot. Aggregation of results in the mobile robot. Okay. The fuzzy output needs defuzzified and its crisp value has to be determined for output to take a decision. from the combined fussified output for four fired values. Okay, you can observe here. Therefore, robot should be delivered by some degrees towards right respect to the one joining new direction by using the diagram to avoid a collision with the obstacle without making any collisions in the movement of robot. Okay, then the next one is in this approach. The rule is composed of fuzzy incident and functional constraint parts. Consider two inputs. These two inputs are the following logistic states. I1, L low, medium, high. I2, near, far, very far. The rule based of the systems decided by the maximum of feasible rules. The output of ith rule can be expressed by the following. So, you should observe the solution of this problem. Okay. The next module I want to describe, that's the final module. Okay, this is the last module. This module I will go for. This is the last module in this session. The next interesting module I will tell in the next session. That is related to artificial neural networks. Introduction. This is the last module. That is introduction to artificial neural network. Biological nervous system is the most important part of living things in a particular human beings. That's the first point. The second point is there is a part called brain at the center of human nervous system. The third point, in fact, any biological nervous system consider of a large number of interconnected processing units called neurons. Okay. The third point, each neuron is approximately 10 micrometers long and they can operate in parallel. The next point, typically human brain consists of approximately 10 power 11 neurons communicating with each other with the help of electrical impulses. So brain center of nervous system, so gray matter, so cerebellum and spinal cord. Okay, these are the important thing and a basic unit of nervous systems. So here dendrite of another neuron, synapse, soma, like that. Neuron and its working. Figure shows biological neuron. There are different parts in it. So then dendrite, axon, soma, and its synapse. Dendrite, a brush of a very thin fiber. Axon, a long cylindrical fiber. And soma, it is also called as cell body. And just like as nucleus of cell, synapse, it is a junction where axon makes contact with the denders of neighboring denders. So neuron and its working. There is a chemical in each neuron called neurotransmitter. A signal is also called as sense is transmitted across neurons by this chemical. The next point, that is all inputs from other neuron arrive to neurons through the dendrites. So these signals are accumulated at the synapse of the neuron and then serve as the output to be transmitted through neuron. An action may produce an electrical impulse which usually lasts for about the milliseconds. Note that this pulse is generated due to an incoming signal and all signal may not produce pulses with action unless it crosses a threshold value. So also note that an action signal in axon of neuron is cumulative signals arrive at a so dendrites which each summed up at a soma. It's a brain working, of course. how the brain neurons will communicate with each other, how the chemical substances, how electrically they are connected. So what are the impulses will come from the brain. So how the cells are connected in the brain, how they are communicated. So every module I am explaining. This is because this is important for our artificial neural networks. This is very important for our course. In artificial neural network, the first point, in fact, the human brain is highly. The second point, artificial neural network are simply we refer it as neural network, which are simplified models. So of these biological nervous system, and obviously therefore have been motivated by the kind of computing performed by the human brain. So then our next point, the behavior of biological neural network can be captured by simple model called artificial neural network. Here the analogy between BNN and ANN. Okay, just see the simple analogy. How the nucleus, axon, cell body, input, weight, summation unit, threshold unit, artificial neural network. We may note that a neuron is a part of interconnecting network of nervous system and serves the following. The first point is compute input signals. Second point is transportation of signals at a very high speed. The third point is storage of information. The fourth point is perception and automatic training and learning. So we also can see the analogy between the biological neuron and the artificial neuron. Truly, heavily a component of the model that is artificial neuron bears a direct analogy to the biological neuron. It is this model which forms the basis of neural network, that is artificial neural network. So see the artificial neural network diagram, input, weight, summation, threshold unit, output. Here x1, x2, xn are n inputs to the artificial neuron. W1, W2 and weights attached to the input risk links. Artificial neural network. Note that a biological neuron receives all inputs through the entities, sums them, and produces an output if sum is greater than a threshold value. The next point, second point, the input signals are processed into the cell body through the synapse, which may accelerate and retard an arriving signal. The third point, it is this acceleration or retardation of the input signals that is modeled by the weights. The fourth point, an effective synapse which transmits a stronger signal will have a correspondingly larger weights, in a weak synapse will have smaller weights. Thus, weights are here are multiplicative factors of the inputs to account the strength of the synapse. Artificial neural network. Hence, the total input say I received by the soma of the artificial neurons is I is equal to W1 x1 plus W2 x2 etc. Wn xn. Okay, sigma is equal to 1 to n summation is Wi xi. To generate the final output y, the sum is passed through a filter. So, phi called transfer function, which releases the output. Y is equal to phi of I. Just observe the input, weight, summation unit, threshold unit, output. Artificial neural network. A very commonly known transfer function is the thresholding function. In this thresholding function, sum is compared with threshold value theta. If the value I is greater than theta, the output is 1. Else it is 0. Just observe the logic. I greater than theta. I less than theta. In other words, y is equal to sigma is equal to 1 to n. You can observe the summation. Artificial neural network following a figure instead threshold functions. Hard limit transfer function, signum transfer function. Hard limit transfer function. The transformation we have just discussed called hard limit transfer function. It is generally used in perception of the neuron. Phi of I is equal to 1 if I greater than theta 0 y less than or equal to theta. Linear transfer function. The output of the transfer function is made equal to its input normalized and is lies range of minus 1, 1.0 to plus 1.0. It is also known as signum or quantizer function. Just see that phi of I is equal to plus 1 minus 1 if I greater than theta, phi less than or equal to theta. Other transfer functions. Sigmoid transfer function. This function is continuous function that varies gradually between the asymptotic values 0 and 1 per log asymptotic values. So and minus 1 and plus 1 variation and 0 to 1 variation. Okay, just see that log symptomatic and tan sigmoid functions. Okay, phi of I is the transfer functions. Advantage of artificial neural networks. Artificial neural networks exhibits mapping capabilities. Okay, that is they can map input parameters to associated output pattern. The next point is artificial neural networks learn by examples. Thus, artificial neural network architecture can be trained with known examples of a problem before they are tested for their inference capabilities. Okay, unknown instance of the problem. In other words, they can identify new objects of the previous unstrained. Artificial neural network possesses the capabilities to generate. This is the power to apply application where exact mathematical model to problem are not possible. Advantage of artificial neural networks. The next point, the artificial neural networks are robust systems, okay, and fault tolerant, and they can also therefore recall full parameters from the incomplete, partial or noisy patterns. The artificial networks can process the information in parallel at high speed and in a distributed manner. Thus, a massively parallel distributed processing system is made up with highly interconnected artificial neural computing elements having ability to learn and acquire knowledge possible. Okay, knowledge possible. So we learned the important concept here in the artificial neural networks. Okay, so how they are working, how they are related to the human brain. It is designed based on the human brain only. How the human brain cells are working, how the artificial neurons are here. Okay, so how we are communicating with the help of our artificial things, how the nodes are there, okay, how the particular pattern is, okay, how the logic will work, everything we discussed here. Okay, so the this artificial neural networks concepts is very much helps us in the as a heart in the soft computing. Okay, so in the next session I will tell the another module of the beautiful thing of the course. Okay, so I want to stop here by posting the two important questions. Try to answer those questions. Okay, so I want to stop here. Explain the important characteristics of artificial neural network. What is neural network architecture? Explain logistic sigmoid function with example. Okay. Next question is like this. Explain. Explain the important characteristics and the applications of the artificial neural network. Both are important. Try to answer these things. Okay. So I want to stop here. Okay. So because most of the modules are completed in the innovative manner, so uh, try to elaborate those things in the more knowledgeable manner. Okay. Thank you all. Thank you all. Thank you.